Hello friends, today's lecture is Medicinal Chemistry Semester 6 lecture on clindamycin. So let us go straight to the lecture. Let us start with clindamycin. Okay. Clindamycin belongs to the chemical class of lincosamides. These lincosamides are characterized by presence of an unusual 8C sugar, which is thiomethyl amino octoside. Look at this. This is thiomethyl amino octoside. Octoside because there are 5 carbons, 6, 7, and 8. Therefore, octoside. And this is linked via an amide linkage, the CONH linkage, as is shown here, to N-propyl substituted N-methyl pyrolydyl carboxylic acid. That is also known as N-methyl N-propyl transhygric acid. Now, please note here, this N is capital N methyl because it is attached to nitrogen, whereas N propyl indicates a propyl chain, not isopropyl, and therefore that N is small. Now, these compounds, because they are amines, are weakly basic compounds. This structure shown here is clindamycin. So, there is a pyrrolidine, substituent on pyrrolidine, carboxylic acid converted to amide, and this is a 8 carbon unusual sugar. So, these structural features are important. Now, this is clindamycin. Clindamycin, the nomenclature is shown over here. It is named as propyl pyrrolidine carboxamide. Okay, so this is the main, and this sugar is named as an N substituent. Please try to understand this. The main parent chain is pyrrolidine carboxamide with the substitutions, and the sugar is named as a substituent. So this is clindamycin. And this clindamycin is derived from lincomycin. Have a look at the lincomycin structure. The sugar, 8 carbon sugar, is just the same as clindamycin. The only difference at this position, clindamycin contains a chloro, whereas lincomycin contains OH. Okay, that is the only difference between the structure of clindamycin and lincomycin. Just have a look at this slide and you will understand this comparison. This is clindamycin with chloro, and this is lincomycin, which has a OH group. Please try to understand that clindamycin is prepared from lincomycin by SN2 reaction. I repeat, clindamycin is prepared from lincomycin by SN2 reaction. Now you know SN2 reaction proceeds with complete inversion of configuration, and therefore, while going from lincomycin to clindamycin, there is an inversion of chirality at C7. Have a look at this. Chlorine attacks from here and this OH leaves. And so there is inversion of chirality at C7. Coming to mechanism of action of clindamycin. This clindamycin functions as a structural analog of 3' end of pro-met tRNA. Okay. Now, clindamycin is structurally similar to 3' end of promet tRNA. Clindamycin therefore can bind to the 50S ribosomal subunit, and this results in inhibition of protein synthesis by inhibition of tRNA translocation as well as attachment of new tRNA. Now, the binding site and the mechanism of action, that is binding to the 50S ribosomal subunit, and the mechanism of action is shared with macrolides. Macrolides include erythromycin, and other drugs. So, since the mechanism and binding site is shared with macrolide, the cross resistance is also shared with macrolides. Coming to metabolism of clindamycin, there are two major metabolites. The major metabolite is N-desmethyl clindamycin. There is N-methyl group here. You know, in metabolism, N-demethylation of smaller alkyl groups is a very common reaction. So, in line with that, the N-methyl of pyrrolidine is removed during metabolism, or N-desmethyl clindamycin metabolite is formed. The other metabolite is clindamycin sulfoxide. Have a look at this sulfur, and attached to it is methyl. This sulfide gets converted to sulfoxide. So these two are the major metabolites of clindamycin. Coming to therapeutic uses, clindamycin is used to treat certain types of bacterial infections, including infections of lungs, skin, blood, female reproductive organs, and internal organs. Most of the times, clindamycin is used when penicillin cannot be used either due to allergy or due to other contraindications. So this is reserved in case when penicillin cannot be used. This is used in the treatment of severe bacterial infections, mainly aerobic, but also anaerobic infections respond to clindamycin. Pseudomembranous colitis is the most serious side effect, and therefore this is reserved only in case of severe life-threatening infections. With that, we complete